Hi everyone, today I'd like to talk a bit about the quadratics and how to complete the square. When we first learn about quadratics, we are taught it in the general form, ax squared plus bx plus c. For example, it could be given to us like 2x squared plus 4x minus 5. So these ABCs are going to be numbers, and then we have x as the variable. There is an alternate form, which is the completed square form, and you are going to be expected to be able to convert between the two. And the completed square form looks something like this: a bracket x plus some h, close bracket square plus k. So for example, you could have 2 bracket x plus 1, close bracket square minus 7. So one thing to note about these two forms is that these two numbers are the same. These two numbers are a. So you can see here in these two forms, which are equivalent, 2 is in front of x squared and in front of the bracket squared here. In school, usually after we learn the conversion, we learn how to use this completed square form, which is usually used to locate the vertex or to sketch the graph. In this video, I'm going to do something slightly different. The key thing about the completing square form is it's also known by another name. It's also known as the vertex form. So I'm going to approach the conversion in a completely opposite way by first finding the vertex, then doing the conversion. So once again, that's find the vertex first, then use the vertex to complete the square. To find the vertex, we're going to rely on this key fact, that the vertex always occurs at a specific value of x. And that value of x is x equals to negative b over 2a. Where this b and a are from the general form ax squared plus bx plus c. So for example, if we are given the quadratic y equals to 2x squared plus 4x minus 5, then the vertex x here will be given by negative b, which is 4, over 2 times a, which is the coefficient of x squared, which is 2. So in this case, the vertex always occurs at negative 1 for x. Once we have this value of x, we can sub this value of x into the equation to get the value of y. So following through on this example, we would have y equals to 2 times negative 1 squared plus 4 times negative 1 minus 5, which will give us negative 7. This means that the vertex of this quadratic equation, y equals to 2x squared plus 4x minus 5, is at the coordinates negative 1, 7. Now that we have the vertex, let's complete the square. So if you remember, completing the square has this form: y equals to a bracket x minus h close bracket square plus k. In this case, h and k come from the vertex. H is the x value and k here is the y value. So in this example, completing the square gives us y equals to a, which is 2 from the original quadratic. A is 2 in this case, next to x squared, bracket x minus h being the x value of the vertex, so negative 1 squared plus k, which is negative 7. So when we simplify this, our completing the square form is simply 2 bracket x plus 1 squared minus 7. And that's our completing the square form found from the vertex. Now that we have the vertex and the completing a square form, let's talk a bit about how we would sketch the graph from this. There are two types of quadratic graphs that you should know by now. One where the coefficient of x squared, the a number, is positive, and one where the coefficient of x squared a is negative or less than 0. When it's positive, the graph has a shape like this, what's sometimes known as a smiling graph. And if it's negative, it has a shape kind of like this, which is what's commonly known as a frowning graph. In both these cases, the vertex or the turning point is one of the most important points, this being down here and being up here. So these are the vertex of these two graphs. And when we want to sketch these graphs, we already have the vertex from the process that we did earlier. using the fact that the vertex always occurs at x equals to negative b over 2a. So if I were to sketch this graph y equals to 2 bracket x plus 1 squared minus 7, what I would do is, after sketching my axes, x and y, the key thing would be to find this point, negative 1, negative 7. So let's say it would be here, negative 1, negative 7. So I would mark this point on my graph directly. After that, it's a matter of sketching out the shape. But if you're uncomfortable with just sketching it out like this, another important point that you could find before drawing it out is to find the y-intercept. You should know how to find the y-intercept from your work in year 7 and year 8 and year 9, but in case you don't remember, the y-intercept occurs at the point where x equals to 0, and so you can sub this value directly into the quadratic and get the y-intercept. In this case, our y-intercept will be at 0, negative 5. So we can mark that point also on the graph. So 0, negative 5 would be probably somewhere here. So then you can just sketch out the smile, making sure that this graph is symmetrical when you sketch it on your own paper. So there you have it, two very easy to find points, the y-intercept and the vertex, and that will give us the shape of the graph. Especially because once you have the vertex and the y-intercept, that also helps you to determine which direction the graph is going, right? Whether you're going to have a smiling down up shape or a frowning up and down shape. Right, I've gone through the concept of finding the vertex, completing a square form, and sketching a graph, all in detail. Now I'm going to go through one example really quickly, showing you how I can do this really quickly in the test. The problem we're going to be examining is express 16x squared minus 24x plus 10 in the form 4x plus a squared plus b. Now this is a completing the square problem, because you can see here it's a quadratic that's been turned into a bracket squared plus something, a constant at the end. This problem is slightly different from the ones that we've been doing before, because previously our completing the square had the form a bracket x minus h squared plus k. But don't worry, we're going to do this using the original method, and then I'm going to move the a into the bracket later. So we have one final step, and that's going to require us to use the laws of indices later. But if we're trying to express this in vertex form, the first step, of course, is to find the vertex. So I'm going to find x of the vertex by doing negative b, which in this case will be negative 24, over 2a, so 2 times a, which is 16. This gives me 24 over 32, which is the same as 3 over 4. With that, I can sub x in. So then I will get y of the vertex, which will be just 16 times 3 over 4 square minus 24 times 3 over 4 plus 10. 16 times 3 over 4 square is 9. 24 times 3 over 4 is actually going to be 18, so plus 10, so this gives us 1. So with our vertex being 3 over 4, 1, that means that our completing the square form is going to be a 16 bracket x minus 3 over 4 square plus 1. Now to move the 16 into the bracket, right, what this means is that you need to multiply in 16 into the bracket for both terms, usually when you expand it. But the key thing here is that instead of just expanding that bracket directly, you have to remember that there's a square here. So when 16 goes into the bracket, you're not going to multiply the bracket by 16. Actually, what's happening here is 16 is going into two brackets. 16 is going into x minus 3 over 4 and x minus 3 over 4. So what this means is 16 has to be split up into 2, so it's going in as 4 and 4, because that's the square root of 16. So what that means is this gives us 4 times x, which is 4x, as desired here in the exam, and then 4 times negative 3 over 4, so 4x minus 3 squared, then at the back there that's still plus 1. because 16 doesn't affect that. 3 close bracket square plus 1. Now if I were to sketch this graph, it would simply be a matter of drawing the axes, marking 3 over 4, 1. So let's say here is 3 over 4, 1. And then finding the y-intercept, which I find by simply substituting in x equals 0. So if x is 0, then 4 times 0 minus 3 is -3. Then square that is 9 plus 1. So then the y-intercept is 0, 10. So I mark 10 somewhere on my graph as well. Then I draw the curve according to the shape. Okay, making sure that it's symmetrical across my vertex. So you don't have to draw this dotted line, but the point is that you have to have it symmetrical across that. And there you have it. That's how completing the square and sketching the graph from it. See you next time, everyone. Bye.